Well, hello, Patriots. Welcome back. I am Mr. Love, aka the Math Patriot, bringing you another lesson in the fun and exciting world of high school geometry. Actually, we're going to do something a little bit different today. My class wanted to say hi to y'all. So, say hi, class.
Hi, class. Hi, class.
Y'all just blew out their speakers. Y'all know that, right? Okay.
Ellen, everybody using headphones.
Oh, boy. Okay. All right, so we finished up the proof section, and now we're moving on to parallel lines. The whole concept of this is that we're going to be taking parallel lines and learning how parallel lines and transversals work, and then eventually using those to start building bigger and better shapes, using that to build triangles, build quadrilaterals, and that sort of stuff. I realize that in some of your previous classes, you may have gone through and found out or learned about, there's 180 degrees inside a triangle or 360 degrees inside a quadrilateral. And so it would technically be possible for us to solve some of our problems in this unit using those properties. You'll see those in our last three examples today. However, I'm asking you to just kind of table that, put it on a shelf for now, and not use those, only use the stuff we've actually covered so far in this course, okay? So let's not jump ahead and do other things. All right. We may have to pause here in a minute because my local class is having problems not laughing. Apparently I'm hilarious. Okay. So first off, parallel lines. All right, parallel lines are always going to be coplanar. Now, the reason that they're coplanar, I mean, if you look in just any sort of just three-dimensional situation, I usually use the classroom, except for when I'm recording, because my YouTube students can't see it. But if you're talking about two parallel lines, I mean, these two here are parallel to each other, correct? Yes. They're also on the same plane. All right? Now, these two down here in yellow are also parallel. They're coplanar, right? Well, what about if I did the top right edge as well as the bottom left edge? Are those coplanar?
Yes.
Right, because we've got that plane that passes through, and I can't really draw that very well, but a plane that passes through diagonally through that cube. Okay, so they are coplanar. Now, I start talking about three parallel lines, and all of a sudden those might no longer be coplanar because I've got, this one, and the bottom one, and they are parallel to each other, but they're no longer coplanar. Okay, now, it's an important distinction, though, because skew lines are lines that do not intersect and are not coplanar. So if we look at our, let me use an orange now. Look at our cube here. This one and that one don't intersect, but they're still, or they don't intersect, they're not on the same line, therefore they are, or not on the same plane, therefore they are skewed, okay? Parallel planes are planes that do not intersect. So on my cube, give me two planes that would be parallel to each other.
The top one and the bottom?
Yeah, the top and the bottom, the front and the back, the left and the right, those are our three sets of parallel planes. Okay. So let's go through here and talk this through. We want to find all plane, that should be planes, that are parallel to plane DEH. Well, which one is DEH? Which plane is it? Left, right, top, or bottom?
Left side.
Okay, there's plane DEH. Which planes are parallel to that? Yeah, just my right side over there, which is plane BCG. Pick 3 points on there that are non-collinear and you're good. All right. Now we want all segments that are parallel to AB. Well, AB is right here across the top edge. Which ones are going to be parallel to that? Carolyn?
EF.
Okay, EF is one. Segment EF across the top. What else we got?
HG.
HG, all right, down there is good. And what else?
DC.
DC Comics. All right. Detective Comics is redundant. Yeah, I know. All right. All segments that intersect GH. Well, GH is our bottom rear edge. So what all intersects it? Yeah, DH. Oh, yeah, DH is there. What else? EH, yes. CH? There? Oh, CG is what you said, sorry. And then my last one is
FG.
FG. All right. Now we want all segments that are skew to CD. All right. What do you got? EH, yes. EH is skew to it. What else? EF. Okay, here's the problem with EF though. EF is sitting parallel to DC because there's that plane that passes through diagonally that way. So EF does not work. All right, what else? FG works. There's two more. EA works. EA Sports. To the game? No, it's in the game. All right, what else you got?
I don't play.
FB. Oh, I probably shouldn't have said that. I'm going to have a copyright issue now. I'm going to get flagged for copyright infringement on my channel that makes no money. Okay.
Do you make money off YouTube?
No, I just said I don't make any money. I got to get about 750 more subscribers and have about 10 times the amount of hours watched as what I get now. So that's why I'm talking directly to the YouTube people, so that they feel included and they tell their friends to come listen to our classroom.
A bunch of fake accounts.
Yeah, by the way, if you have a whole bunch of fake accounts, no, I can't say that. They would not allow that. Okay. Do a giveaway.
Yeah, give away calculators or something.
Give away calculators. Yes.
Giveaway for us.
The next 10 people to subscribe will get one of my classroom sensitive calculators. No, no. Not going to work. Okay. So transversals. Now, a transversal line is a line that intersects two or more lines at a different point. So in this case, T is my transversal line. It cuts across and creates all 8 of these angles. There's my transversal line. Now, honestly, I don't like the definition of interior angles here. Angles that lie between two transversals. That shouldn't say transversals. That should say they lie along the between two lines that intersect the same line, which that same line there is the transversal line. Anyway, the picture shows it a lot better. Interior angles are 4, 3, 5, and 6. Okay, they're the ones on the inside of the two lines. Now, our exterior angles are going to then be what? 1, 2, 7, and 8. Now, we could have transversals that go the other direction. And so in that case, my interiors end up being here, and my exteriors end up being there. Okay? So it just depends on inside, outside, whether you're vertical, horizontal, or even diagonal. And that can get even further complicated whenever you have two transversal lines that go across. So we'll have a few where we practice doing that here in a minute. Okay, definitions. First off, consecutive interior angles are interior angles, so we're not talking about 1, 2, 8, or 7, that lie on the same side of the transversal. Well, that would be 3 and 6. They're on the same side of the transversal, and they're both interior. Also, 4 is consecutive interior with 5. Okay, 3 and 6, 4 and 5. Sir?
How do you know which one's which side?
Okay, we're not saying that 3 and 6 are the only ones. We're saying that when we identify, when we have a transversal, and I've got information on these two, then I need to say, oh, those two that are identified are consecutive interior angles. Because when I'm looking at them, I see that these two are on the inside, on the same side. They are consecutive interior. That's the style of thing we're doing, where we're going to come in and have to do math with that later on. Okay? All right, alternate interior, same idea, except they are the non-adjacent interior angles that lie on opposite sides of the transversal. So let's look at number 3 here. First off, the fact that it's internal or interior means it has to be 4, 5, or 6. But because it's non-adjacent, that means I could not use 4 as my alternate interior. Also, they lie on opposite sides means I can't use 6 because 6 is on the same side. So my alternate interior is 3 and 5. Also, which one's alternate interiors with 4? 6. Okay. Next up, we've got alternate exteriors. Same idea, right? So 2 is going to be alternate exteriors with 8, and then 1 with 7. Okay. Those 3 concepts. Oh, I'm sorry. I take it back. There's one more. Corresponding angles are pairs of angles that lie on the same side of the transversal and on the same side of the intersected line. So same side of the transversal and same side would be like 1 and 5. They're both in the top left corner. Okay? 2 and 6 are both in the top right. 4 and 8 and 3 and 7. Okay, those 4 different sets of patterns. Okay? We've got the consecutive interiors, alternate interiors, alternate exteriors, and corresponding angles. Those are one, I know you just learned them right now, but I need you to commit those to memory as quickly as possible, identifying those patterns. They're going to come up over and over again, not just in this unit, but in the rest of the course. So it's one that I need you to have down. They're right up there in importance with vertical angles and linear pairs. Okay, you've got to have those guys down pat. All right? So let's go ahead and classify these. Number 10 and 6. So angle 10 and angle 16, not 6, thank you, 6. Okay, before we identify their pair or their relationship, which one is a transversal line that connects 10 and 16? Q. Yeah, it's line Q as my transversal line here. All right, now knowing that, what are 10 and 16? Alternate exterior angles.
Can we just go like A?
Let's actually write it out, because one of the problems we're getting into in geometry is if you start abbreviating everything, then all of a sudden your abbreviations lose meaning because there's too many to keep track of. I'm even going to put Alt X. Yeah, that would probably be fine. But let's not abbreviate all the way down to just a single letter. Okay. 4 and 12. Angle 4 and angle 12. Okay, in this case, what's my transversal line?
N.
Yeah, now it's N cutting across them. And angle 4 and angle 12 relationship is corresponding angles. Y'all are good. All right, now 12 and 13. 12 is here, 13 is there. Transversal line is Q, and the relationship is
Consecutive interior angles.
consecutive interior angles. All right. And then now 3 and 9. Where's 3? There's 3. There's 9. Transversal line is N. And the relationship? Alternate interior angles. All right, any questions on where those, on how to identify those? All right. Let's jump on down to the corresponding angles postulate. Now, we're about to take a break from the note, or what's actually on the page. And 3 and 9, 3 and 9 was alternate interior angles. All right, we're about to take a break from things. I'm going to show you how to combine basically what we learned from Unit 1 and Unit 2 to learn stuff for Unit 3. Here's our if-then. If 2 parallel lines are cut by a transversal, first off, this idea of parallel here is extremely important because earlier those lines weren't parallel. Now they are. Oh, by the way, on the picture, the symbol for parallel is this arrow. You could have 1 arrow, 2 arrows, and keep track of multiple sets of parallels in one picture. But when they're cut by a transversal, then each pair of corresponding angles is congruent. So I know that angle 1 is congruent to angle 3, angle 2 is congruent to angle 4, and so on. Okay? Notice that one is listed as a postulate. Now, I want to do a brief little exercise, and I don't believe you have room to do this on yours, but I want to do a brief little exercise to show you how you could take that information and move forward with it using the proof process. Okay? So, let's just say that given angle 1 is congruent to angle 3, which is our proof or our corresponding angles postulate. I get that, but we're just going to go ahead and state that as our only given here. So kind of ignore all of these for a minute. Given that angle 1 is congruent to angle 3, prove angle 1 is congruent to angle 5. Any thoughts on how I would do that? Prove that angle 1 is congruent to angle 5. All right, what do we got? What's our first step?
You could use the substitution property or the reflexive property.
Okay, yes, you're right. Let's get our given in here first. Angle 1 is congruent to angle 3 is given. Okay, you said substitution, but we don't have anything to substitute into yet. Okay, and I'm going to try and do it without going down to angle measures. I'm going to try and keep it on the angle level as opposed to the measure level. All right. Yes.
Is angle 1 vertical to angle 7?
Angle 1 is vertical at angle 7. Yes. We could use that. Do we want to use it?
Yes.
Okay. So now we got angle 1 is congruent to angle 7. And what's my theorem that tells me that? Yes. The vertical angles theorem. Okay. Now that I know that angle 1, and I guess I should probably do it this way. I'm going to go ahead and keep that one circled. Okay, those two are congruent. Now what? Yeah.
Okay, so 7 is congruent to 5, and if 1 is congruent to 7, that means that 1 is congruent to 5.
Well, okay, you're right.
But that's not how you put it down.
Now, but remember I said we're going to forget that 5 is congruent to 7. So maybe we actually went the wrong direction with this. Maybe we shouldn't have gone and said 1 and 7 are vertical angles. Maybe we should have said that 3 and 5 are vertical angles. Okay, so now that I've got angle 1 is congruent to 3 and 3 is congruent to 5, what does that then mean? Transitive property says angle 1 is congruent to angle 5. And that's transitive. And now I got it. Okay, yeah.
So is this still technically proofs?
Right now, yes, this is still technically a proof, but bear with me for a second, and I'll get to the purpose of it in a second. Okay? I know you're seeing there's something more going on here, and you're right. Okay? All right, I'm going to do another one now, using that exact same given. So I'm going to do the exact same given. Prove that angle 3. Well, actually, yeah, angle 3 is congruent to angle 7. So again, the only information we have now is our given that 1 is congruent to 3. So angle 1 is congruent to angle 3, given. What's next? Yeah.
You could say that angle 1 is congruent to angle 7.
Okay, now I can use angle 1 is congruent to angle 7. And that's, again, my vertical angles theorem. And now what? Transitive property. Angle 3 is congruent to angle 7. Done. Okay. Simple enough. Now let's do another one. We can go crazy on this stuff. Let's go with angle prove angle 2 and angle 3 are supplementary. Now this one's a little bit more difficult. Okay? Again, we know angle 1 is congruent to angle 3 as our given. What can we do next? Remember, I've got to incorporate somehow angle 2, and I've got to incorporate the idea of supplementary. So I know that these two are congruent right now. Is there any supplementary things I can use involving angle 2? Yeah.
No, both are angle 2 now.
With angle 2, no? What were you saying? Why are 1 and 2 supplementary? Oh, what do we call this pair right here? Linear pair. 1 and 2 are linear pair. And so we know that angle 1 and angle 2 are supplementary by the, anybody remember? Vertical pairs are supplementary? Is the supplement theorem. Okay? Now, here's that the trickier one we had from Unit 2. I've got that 1 and 2 are supplementary, but 1 is congruent to 3. Which one told me that angles congruent to supplementary angles are supplementary? I said that backwards, but that if I have these two, what allows me to essentially stick the 3 in there instead of the 1?
Supplementary congruent theorem?
Close. Congruent supplements theorem. So angle 2 and angle 3 are supplementary. All right. So here's what we just did. And I said there's a point to this. We started off assuming that 2 lines are parallel. So if 2 lines are parallel and they're cut by a transversal line, then the postulate tells me that corresponding angles are congruent. However, if corresponding angles are congruent, then angle 1 is congruent to angle 5. But what is the relationship between 1 and 5? What's their pattern that we saw earlier?
Alternate exterior angles.
Alternate exterior angles. So what this means is that alternate exterior angles are congruent. Okay? What about in blue down here? 3 and 7 are alternate interior angles. So if 2 lines are parallel and they're cut by a transversal and corresponding angles are congruent, then by definition, well, not by definition, but by our proof we just did, alternate interior angles must be congruent. Also, we know that consecutive interior angles, because 2 and 3 are my consecutive interiors, those two must be supplementary. Now, do you really want to go through and have to do those sets of 3 steps every single time that you have a transversal? No. Or could we just package this whole thing up and give it a name and call it a theorem?
Yes.
There we go. There's your alternate interior angles theorem, your consecutive interior angles theorem, and your alternate exterior angles theorem.
Wow.
That says, notice they all have the exact same hypothesis. If 2 parallels are cut by a transversal, then each pair of alternate interior angles is congruent. See, here's what we're doing for the very first time. We're giving you guys the ability to take the knowledge that you've had and extend it on your own using proper methodology of proving things. Methodology is the proper method of it. And you're not just assuming things, you're testing them to see if they're true using that reasons column over on the right. Okay? And it's sort of like that thing of my 4-year-old whenever he does his homework every day and he's counting for Head Start and he's practicing doing his numbers 1 through 20. He does this every single time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16, 19, 20. He skips 15 every time, and he skips 17 and 18 every single time. Because he's been told what those numbers are, and he believes it is true because somebody that he trusts told him, me, because I don't lie to my kid, right? But even though I told him the truth, number one, he's reliant on me giving him that information. But 2, he messes it up sometimes, right? Because he's just inexperienced with it. Up till now in your education, you've been told everything that this is true. And you're reliant on your teachers and your parents and all the adults in your life and all the older students in your life telling you true things. Now we're giving you the ability to actually test those for yourself and take it further than they've taught you based on the proving process and knowing that other things are true. That's why the proving process was necessary. Okay? That's what we're doing with it. Okay. Enough educational methodology stuff. Let's just move on to this. Bottom line, Two parallel lines are cut by a transversal. Then you've got corresponding angles are congruent, alternate interior angles are congruent, alternate exterior angles are congruent, and consecutive interior angles are supplementary. Whew. All right, let's use it. Quick question. What's your quick question?
So theorems and postulates can have the same like point, because there's a 3.1 theorem and a 3.1 postulate.
Okay, yeah. So the name of it, 3.1 postulate versus 3.1 theorem. First off, there's a reason why I don't use those numbers. The reason that's 3.1 for both of those is because it's chapter 3 and the first postulate, chapter 3 and the first theorem. Now that only works for those numbers only have any sort of meaning within the textbook that we're using, which is McGraw-Hill. Now, if you, for whatever reason, were to move at Thanksgiving or Christmas and go to a different school, and you start going to school in Hutto, and you walk in and say, "Oh, ma'am, I know exactly why that's true. That's because of postulate 3.1." Well, what if they're using the Glencoe book and they put theirs in a different order? So that doesn't have any meaning outside of a textbook. That's why I always use the names of the theorems and postulates. So to answer your question directly, yes. The reason that they have the same number is because of just a numbering system the textbook chose. But that's why I don't use them. Okay. You see me calling these corresponding angles theorem, the alternate interior angles theorem. Okay. So in our figure, we know that measure of angle 9 is 80 degrees. And measure of angle 5 is 68 degrees. Let's tell which postulate or theorem we use to find out what 12 is. Well, over here, angle 12. What do we think? How much is it going to be?
100.
It's a linear pair, making it 100 degrees. Good, you're both right. So we got 100 degrees. But what theorem is that? That says that a linear pair is supplementary.
Supplement here.
Supplement theorem. All right. Next up, go ahead and write that in. 100 degrees. Angle 1. It's what? You got it. I see it in your face.
22.
22?
What? Okay, I got this one.
Oh, I see what you did there.
What?
It's wrong, but I see what you did there. He was basically trying to do something with these two. However, since these two here are the parallel lines, the transversal is going to be P or Q. So we got to relate it over to this side somehow. All right, what do you got? Noah?
80.
It's going to be 80 degrees. Why? What's the relationship between 1 and 9? Don't say they're congruent. What's the name? They're corresponding. So it is 80 degrees because of the corresponding angle postulate. All right, now angle 4 is there. You got a couple options here. I'm interested to see which one y'all pick. It's not 22. Yes. It's 100. You're right, it's 100. Why?
Oh!
Well, first of all, it's a linear pair, and it's
Okay, so yes, you're right. It's a linear pair with angle 1, so I could use a supplements theorem. What else could I use? Corresponding angles postulate with 4 and 12. I'm going to choose to write it as the supplement theorem because it's less writing.
what?
What was the other one?
The corresponding angles postulate was the other one because 4 and 12 are corresponding angles, therefore they are congruent. All right, angle 3. Yes, sir. Sorry.
Is it 80?
Angle 3 is 8?
80.
Oh, 8. Oh, okay. Angle 3 is 80. Yes.
I thought you said 82.
Why is angle 3 80 degrees?
Because of not the corresponding, the supplement.
Okay, yes, we could use a supplements theorem again here. Let's actually use one from this unit, though,
That's
from today's lesson. Let's start at angle 9.
alternate interior angle.
Well, 9 and 3 are alternate interior angles, so it's the alternate interior angle theorem. Yes, ma'am. All right, angle 7 here. Okay, now this one is not going to be 80 because we're on
I
transversal line Q. What do you got, Sydney?
Is it 68 because 5 and 7 are vertical?
Yes, 5 and 7 are vertical angles. So it is the vertical angles theorem. States that vertical angles are congruent. And now our last one, 16 here. Yeah,
Wouldn't it be 112?
112. Where are you getting that from? Where did 112 come from?
Supplements theorem?
Not supplements theorem. Because you're pulling that saying that 7 and 16 are supplementary, right? That's your logic. So if this is 68, that's supposed to be 112. What theorem tells us that these two are supplementary? These are not alternate interior angles, though. They are... No, they're interior, but they're on the same side. Means they are consecutive.
Oh, what? Why is
So
it
it
rainbow?
is 112?
It's rainbow.
Yeah, it's a rainbow pen.
So the answer is 112?
Yes, the answer is 112. For the consecutive interior angles theorem. I know that's hard to read. That's why I don't use it very often. All right. Is that making more sense of where we find all that stuff?
Yes.
Okay.
I understand.
All right. 3 more examples. Now, you'll notice on these, here's where those other shapes come in, triangles. I'm going to ask you guys to kind of not use your triangle knowledge for a minute. And we're just going to do our parallel lines. So I need to find the value of x or y here. And I think x's are probably going to go first.
Yeah, two of them.
Okay, now first off, realize that even though I got more stuff drawn on here, we've still got a transversal because I've still got 2 parallel lines, and then I've got this transversal cutting across. So my 2 angles with x's in them, what is their relationship first off? Yeah.
Wouldn't they be parallel?
Well, yes, the lines are parallel, but what about the 2 angles? Corresponding angles. Okay? So, now explain your reasoning.
Oh, for the corresponding? Or what?
I'm just going to say here the corresponding angles theorem, because that tells me that they are congruent. So, 5x minus 5 is equal to 4x plus 10. All right, how am I going to solve that?
Subtract 4x.
Subtract 4x on both sides gives me an x on the left. Then add 5 on both sides gives me a 15 on the right. Hey, I like one-step equations. Did you just say yeet?
Yes.
No, we don't yeet, we don't dab. We are not that cool in here. Oh, Lordy, he just dabbed. Okay.
No, we're too cool for that in here.
All right. What about my y's? All right, so this angle is a...
Is it a No, not corresponding.
It's not corresponding.
Consecutive?
It's consecutive interior with this one down here, yes. What do I know about consecutive interior angles?
They're congruent.
They are not congruent.
They are not congruent.
They are supplementary.
They are supplementary. Sorry, let me finish writing. For once, you are getting ahead of me, right? Okay, consecutive interior angle theorem says that consecutive interior angles are supplementary. So 6y minus 4 plus 4x plus 10 equals 180. Yeah, consecutive interior angles theorem is what it says. All right, but I got to plug in my x there. Okay, so how am I going to get rid of the x? Because I know that x equals 15. So 6y minus 4 plus 4 times 15 plus 10 equals 180.
4 times 15 is 60.
I like how you just panted that. Okay, yeah. 4 times 15 is 60, plus 10 is 70, minus 4 is 66. Oh, right, 9 equals 180. Sorry, I gotta subtract that off. So subtract 66 gives me 6y is equal to 114. Then divide both sides by 6. You might want to take a stab at what 114 divided by 6 is?
Not 19.
Flip you.
What?
19. Did you do that in your head?
Yes.
Awesome.
Well, I mean, I did it because 120 was 20. So it's just 96 times that.
Oh yeah, you're right. 6 times 20 is 120. Subtract 6 off is 9. Yeah, there you go. That works. Okay, guys. I know that math thoroughly invigorated your spirit, but we got to get this thing finished. All right. Come on. Let's get it done. Okay, we got to be careful on this one. Let's do, guys, come on. Let's do the x's first. Again, I got a set of parallel lines with a transversal line cutting it. What do I know about these two angles? What are they?
Congruent.
They're not congruent.
Consecutive interior angles. I can't talk.
They're consecutive interior angles. And so the consecutive interior angle theorem tells me what?
They're supplementary.
They're supplementary. So 15x plus 30 is equal to, I'm sorry, I almost did it too. Plus 10x equals 180. What if I put the x on there? Clean up my one, actually look like a 1. Okay, let's combine like terms. They're on the left. 25x is equal to, subtract the 30, gives me 150. And please tell me y'all counted quarters enough to do this in your head.
5.
6.
Bruh.
Hey, you know what? I got bad multiplication days too. Was it this class that I like messed up the multiplication like 6 times in one class period? Yeah. There was one class period like 2 weeks ago where I seriously like misdivided in my head or mismultiplied like 12 times in one class. Okay, now for the y's. What am I going to do with my y equation here, or y expression? Sir? Okay, so the assumption here is that this is a 90-degree angle, and that's what he just said. And that's everybody's first instinct. Now, by the way, you're right. But why is it equal to 90 degrees? Okay. Shh. You said because they're parallel, but what does that mean? Okay, they're consecutive interior angles. And so what you're doing there is you're saying consecutive interior angles are supplementary, and in your head you're subtracting the 90 off and saying 3y plus 18 equals 90. That is by completely right. However, we're new to this, we're fresh to this. I don't want to accidentally write on our notes anything that might give you the impression that consecutive interior angles are congruent, because it's already been said like 4 times mistakenly throughout the class today, right? Anytime we talk about consecutive interiors, people want to say they're congruent. They're not. They're supplementary. So by the same theorem here, I know that 90 plus 3y plus 18 equals 180. When you guys get more experience, I'm going to be okay with you jumping straight to that guy's equal to 90. But for now, I don't want to give that mistaken impression. Okay? So that gives me 3y plus 108 equals 180. So then 3y is equal to, well, 108 minus, I'm sorry, 180 minus 108. 72. And then divide that by 3 and we get y equals Anybody got it? 24.
24.
Way off.
All right.
Why is this the easiest thing?
Why is this the easiest thing ever? Because you just spent 2 weeks doing proofs, and that was more difficult. Okay, shh, guys, we're going to keep it down to a dull roar. The microphone can't pick up my voice whenever y'all are talking. Also, you know, my voice is so important, right? Although it is the closest one to the microphone, so I don't know. But in all reality, guys, seriously, for all you guys out in YouTube land, the reason they're so, invigorated in class today is this is the last class period before a long holiday weekend, so they're ready to get out of here. So, all right, one more example, and then we are done with the lesson. All right, example 6, find the values and explain our reasoning again. Now, this one, you got to be careful of that line that cuts across. I'm going to do the x's first. And let's look at these two angles. 3x and 5x minus 20. What is their relationship first off? What do we call that?
Alternate.
Interior?
Alternate interiors, yes. Now, so the alternate interior angle theorem tells me what? What are the alternate interior angles?
They're equal.
They are congruent. Therefore, their measures are equal. And so, yes, you put them equal to each other. 3x is equal to 5x minus 20. Yeah, you can do it the other way. 5x minus 20 equals 3x. You'll get the same answer either way. All right, so my next step is going to say what?
Subtract 5.
Subtract 5x.
Yes.
Negative 2x equals negative 20. X is 10. Okay. Almost done. Almost done. Now we got to figure out what to do with our y's. Anybody want to take a wild stab at how these two angles are related? Okay, I'm hearing corresponding, I'm hearing alternate interiors, I'm hearing all that sort of stuff. Here's the problem. The three angles that make up those two angles, the three lines. We got this one here in blue, this next one here in blue, and there we go. Nowhere in there do I have two parallel lines in the three lines that make up these two angles, which means you can't directly use the properties of transversals to get there. Now, if I expand out my logic, though, let me redraw this. If I draw this without this diagonal line that's interfering with things, I know that these two angles here are consecutive interior angles, right? However, I've got this guy cutting across. So my alternate interior angles here, my consecutive interior angles are actually 4y and that whole thing.
So that line would be bisected.
Wait, hold on. Let's not say the word bisect, because bisect means it cuts it exactly in half, and we don't know that. It does cut the angle into two. And so then the angle addition postulate says I could add these two together to get the full angle. So I'm going to be using the consecutive interior angles theorem. And that tells me that, 4y plus the greater angle equals 180. And that greater angle there is 2y plus 3x. Are we all right with that?
Sure.
You don't sound very convincing. Yeah, well, since we had to use that whole thing, we got 2y plus 3x. That's where that comes from. Now let's plug it back in. Well, hold on, take it back. 2y plus 4y is 6y plus 3x, but x is 10, so that's 30 equals 180. And now, what?
Why did you distribute it?
Because there's nothing to distribute here. The question was, why don't we use the distributive properties? Because there's nothing to distribute. What? Oh, also, the only reason I put the parentheses there was just to show you it's this, that it's the 4y plus the greater angle. That's the only reason the parentheses are there at all. Okay, let's refocus here. 4y plus 2y was 6y. 3 times 10 is 30. Then over here, 6y drops down. Subtract 30 gives me 150. And y equals 25. All right, last example done. That's the lesson. For all of my patriots out there on YouTube, I'm going to go ahead and cut this off before I talk about homework. And as always, stay patriotic.